evening and welcome back to my channel. In this particular video, I'll be teaching you how to configure OSPF in Huawei routers. So in the HCIA Datacom lab guide, this is lab 2.2 titled OSPF Routing. So I'll just read the foreword about this lab. So OSPF, Open Shortest Path Protocol, is a link state interior gateway protocol IGP developed by the Internet Engineering Task Force. So currently we have two versions, version 2 and version 3. Version 2 is used for IPv4 while version 3 is used for version 6. So the link state protocol, OSPF, has the following advantages. Number one, multicast packet transmission in order to reduce the load. So it doesn't broadcast its packets, but uses the multicast address 224.0.0.5 to communicate with all routers that have been enabled with OSPF, or 224.0.0.6 to communicate with the DR or the DR rather. OSPF also supports variable length subnet mask and therefore can be able to implement CIDR. It also supports load balancing. When you have two equal cost routes, then data is forwarded. Data is forwarded 50-50 among the equal cost routes. Then we have the security or security feature, which is packet authentication. In this lab, we are going to be configuring OSPF authentication so that only routers that are authenticated can be able to communicate via OSPF. So no stranger can come in. So with these advantages, OSPF is widely accepted and used as an interior gateway protocol. In this lab, you will understand basic OSPF configurations and principles by configuring single area OSPF. If you want to learn how to configure multiple area OSPF, you need to take the next level of this course, which is HCIP.com. So the objectives to learn by the end of this lab, you should be able to learn how to configure OSPF using the basic OSPF commands, how to check the running status of OSPF, how to control OSPF route selection using costs. So we're going to change the cost of one of the interface in order to change the path via which packets are going to pass through. We're also going to understand the advertisement of default routes in OSPF. How do we advertise a default route in OSPF? And we're also going to learn how to configure OSPF authentication. So let's begin. This is the network topology. We are going to simply use the network topology from the previous lab. And in fact, in step one, we are simply supposed to configure the name and we're going to configure the name and the IP address of the physical and loopback interfaces. So that is step one. So I'm simply going to reopen I'm simply going to open the previous lab, which was the lab on static routes and IPv4 configuration. So I'll come to ENSP, open, then I have it here. So I'll just reopen this. And then I can start the devices as I save this project as. So I'll just save it as lab 2.2 OSPF routing. So I'll save it like that. And now I can open. I can open the CLI, the command line interface. Now, the only difference between our topology and the topology that is being used here is on this interface that is interconnecting R2 and R3. So we have GE004 and 003 on router 3, but on ours, we're just using 000 to interconnect both of them. So interconnection between R2 and R3, we are connecting it through 000. Otherwise, R2 and R1 via R3, then R1 and R3, G001. So let's begin. So the only thing we had done on this router is to configure static routes. So if we do, for example, display IP routing table, enter IP routing table, we can see that indeed we have some static routes. Like on R1 we had configured a default static route. We also have a static route to the loopback interface of R3. So we can simply undo this in order to remove them from the routing table. So I can do that by going to system view and then undo IP route static. Then if I do question mark, you see I can be able to undo each one of them by typing the IP address of that static route, or I can simply write all in order to delete all the static routes. So I'll simply use all. So that, then yes, Y, then enter. So right now, let me just quit and do terminal monitor. So if I do display IP routing table, then I only have direct routes. As you can see. I do not have any static route because I've deleted them. So I'll do the same on this one and do terminal monitor, undo IP route static all. Yes, enter. Okay, I'll do the same to R3. So undo terminal monitor, system view, then undo IP route static all. Enter. Yes, Y, enter. So with that, I no longer have any static route configured. If I ping the loopback interface over R1, we can see in the background here the loopback there is supposed to be 10.0.1.1. If I ping it, I should not be able. So Control C to stop that ping, just to get out of it. Okay. So now we are sure. We can also use commands that we've used before, like display IP interface brief. To look at the IP addresses. So we have configured the IP addresses, which is good. So for the interconnected, and their status is up. Physical and protocol status is up. So we have the IP addresses, which is good. Display IP int brief. So I also have the IP address for this one, and also the loopback 0. And the one connecting router 1. So this is on R2. On R3, if I do display IP int brief, then I have the two links connecting to router 2 and the other one connecting to router 1, this one. Then I have the one that is the loopback interface. So I have the IP address and the names are also configured. So we can go ahead now and skip right away to step number 2. So as you can see here, at this point, only direct routes should exist on the device. So we've already deleted. We've deleted the static routes. Okay, so on step 2, we want to complete the basic OSPF configuration. So to do that, we need to create an OSPF process with an ID, process ID. Otherwise, if no process ID is specified, then the default process ID will be used. After that, we are going to create an OSPF area and specify the interface on which the OSPF is enabled. So the command for that is area 0 And then after that, we specify the interface using the network command. So that's how we do that. So let's do that on R1. I want my topology to be on the background, so I'll just clear that. UTM. So let's go OSPF 1. Now the next thing I can enter here is the router ID. But in this particular lab, they haven't used a particular router ID. They want the router to automatically pick it. So I'm not going to use it, but I'm going to demonstrate how you can be able to maybe change it much later. So I'll just press enter. Then we're going to get into the OSPF view. The next thing we're supposed to do here is to enter the command area. If we do a question mark, we can see that we can either specify the area as an IP address, the area ID, or simply as an integer between 0 and this particular value here. So we just want to create the backbone area. So area 0, then enter. Then after that, we use the network command. So network question mark. The next thing you need to do is to enter the network address or the address of the particular interface. So let me just clear here so that we can be able to see the networks we have. So the first one is this one here, the loopback interface. So we can simply do 10.0.1.1 like that. Then the next thing we are supposed to do is to use the mask. So question mark enter. So the wildcard mask. So because it's /32, it's going to be 0.0.0 like that. Then enter. So we do the same for the other interfaces, G003 and G001. So we do network and then 10.0.12.1. Then we specify the mask 00255. So that will be the inverse mask. Then we do the next one, network 10.0.13.1 0.0.0.255 like that. So that is how we specify the interfaces that have been connected to this particular device that we want to participate in OSPF. So we do the same for R2. So in R2 again, we do UTM. Let me just quit, and then UTM, then system view, and then OSPF. If we don't type the process ID, it's going to get us into process ID number 1, which is the default. So that is what I've just done there. Then we create area 0. Then we advertise network. So we are in router 2. So we start with the loopback 1.2.0.0.0 like that. Then we do the next interface, which is 3. So 1.2.2, then 0.0.0. Now, as you're going to read in the explanation on this lab, when you are advertising interfaces using the network command, you can also specify the mask as all zeros as long as you've specified the IP address of that particular interface and not the network address. Otherwise, the other alternative is to specify the network address. For example, here, we know that the network address is that, then we do like that. So we can also do that. But in this particular example, we want to use the specific IP address for that interface, .2, like that. Then we use all zeros. Then again, we use network 10.0.23.2, the one that is connecting to R3. Then again, we use all zeros. So that's just one way of doing it. Then again, we go to R3 now. So in R3, we can quit, and then we disable that, and then we come back, and then we do OSPF 1, area 0, then network 10.0.1.3.0.0.0. Good. Then again network 10.0.13.3.0.0.0. Then network 10.0.23.30/0, like that. So once we configure that, we can be able to verify. Using the display OSPF peer command. But before we go there, I think it's important that I just insist on this one, that OSPF can run on an interface only when the following two conditions are met. The first one, when the mask length of the interface's IP address is not shorter than that specified in the network command. So the mask should not be shorter. If it's /24, we cannot specify lesser number of ones, maybe more. The next one is when the address of the interface, the address of that particular interface must be within the network range specified in the network command. So that is if when we are specifying the network command, we use the network ID, the network identifier, instead of the specific IP address for that particular interface. And here they say wildcard mask if the wildcard mask in the network command is all zeros and the IP address of the interface is the same as the IP address specified in the network address command, then the interface will also run OSPF. So what I just told you, that you can be able to use all zeros if you specify the exact IP address of that particular interface. So how to confirm on step 3 here, how to confirm that OSPF is running? We can use the command display OSPF peer, which is used to display the neighbors that that particular router has formed. So for example, we can go back to R1. I can quit, I can clear this, then I can do display OSPF peer. Let me use brief for now, BR for brief. So we can see that on area 0, we've been able to create two neighbors. One is 23.3, so that is the interface on router 3, this interface here. And we've also been able to form another neighbor through our interface 003, and that neighbor is router 2 on this interface here on the background, if you can be able to see it. And you can also see the state that we've already formed an adjacency, and therefore we are on full state. Now, if I can just do display now OSPF peer like that, then we can get the individual results of each of the router. So some of the things you get here, for example, is the area that router belongs to. We've interconnected with you via this interface, so you are on our neighbor via that interface. Your router ID is this. So you can see that, for example, router 3 picked this particular value automatically. We did not configure this as the router ID, so it picked the highest interface IP address as the router ID. Then the address is the link via which the address, let me just remember this, router ID and address. Okay, so please allow me to remember that. There's something that I'm missing there. But we can also see that the priority for this particular neighbor is 1. We can see that the DR between these two routers is router 1, the one that has .1, then the BDR is this one. Of course, we know that when it comes to DR and BDR election, we use the router ID. We can clearly see that this one has a higher router ID compared to our own router ID, which is this one, 13.1. So this is our router ID for router 1. Then this one is the router ID for router 3. So because their priorities are both the same, which is the default one, we've not changed, then technically speaking, router 3 is supposed to be elected as the DR. But reason as to why in this particular case router 1 has been elected as the DR is because we enabled we enabled OSPF on router 1 earlier than we did on router 3. And therefore, if you can remember, we said one of the election conditions for DR and BDR is that the election is non-preemption. So we cannot remove the DR after we come in with a better either priority or router ID. Okay, then we can also see the details about the other neighbor. This neighbor is connected to this interface, G003. So this is R2. You can see the router ID for R2 is that particular address. Then we can see that the DR in this case again is router 1, the BDR is router 2. So this is simply the router ID. This is the router ID of the DR and the BDR. Okay. So somehow I'm thinking this value is supposed to be here, and this one is supposed to be here, because the router ID actually it's supposed to pick the loopback interface ID, if I'm not wrong. But anyway, let's leave that for now. Okay, so let's check what we're having here. Okay, display OSPF peer. We've already done that. Display the routes that have been learned through OSPF. So let's do that. There are two ways to see the routes that have been learned via OSPF. Let me clear this. So one way is to use the display OSPF routing table, or just routing, not routing table. Display OSPF routing. So when you do that, it's going to list for you the routes that have been learned through OSPF, and this now shows you the OSPF routing table. This command, it shows you the OSPF routing table, so you can be able to see all the routes, their next hop, the advertising router, so the router ID of the advertising router, and the area that it belongs to, So that's how you do that. Otherwise, you can also use display display IP routing table, and then you specify the protocol. If we do question mark, you can see you can be able to specify any routing protocol. So one of them is OSPF. So OSPF and then enter. So if you do that, then you're able to see the public routing table, but it filters only routes that have been learned through OSPF. Only routes that have been learned through OSPF. So that's why you can see here, under the protocol, we only have routes that have been learned through OSPF. So one of those routes in router 1 that has been learned through OSPF is this one. 1.2, how to go to the loopback of router 2. The cost is 1. The next hop, if we want to go there, the next hop is this link, 12.2. We also have a route to the loopback of R3. Again, the cost is 1. I hope we understand why the cost is 1, because it's a gigabit Ethernet link. And if we want to send, if we get a packet that goes to 1.3, we can send it to this next hop. Similarly, we have the network address that is interconnecting R2 and R3. So if we want to get to that network, we can send that packet to the interface on R2. Okay. So let's move on. What did I want to do? Okay, I just wanted, I'm thinking that maybe we can configure the router ID. I don't know. Let me try it. OSPF 1 router not router ID. Question mark. Control C. Let me clear this. Route all commands that start with ROU. Oh, we don't have any. Let me quit. OSPF 1 question mark. Okay, so let me just see if I can be able to create it here. So router ID, I want us to give it 1.1.1 so that we can be able to differentiate. When you use the display OSPF peer command, we're able to clearly differentiate the router ID with any other address, because when it's the same with the address, it becomes quite difficult to differentiate. So the configuration succeeded. You need to restart the OSPF process to validate the new route ID. So anytime you change the route ID, you have to restart the OSPF process. But let me just hold that for a moment, so that we also do it here on R2. So OSPF quit. Clear that. Okay. OSPF 1 router ID. So for router 2, we give it 2.2.2. Then we go here. System OSPF 1 router ID 3.3.3, so that it becomes easy to differentiate this. Okay, so let me quit. Then I need to find the command for restarting the OSPF process. I want to begin with router 3, so that's why I didn't restart from R1. OSPF1 restart or something. Let me do question mark and recognize command restart OSPF. How do you restart OSPF? Okay, I am forgetting that command for restarting OSPF. We don't have. Or do we have to be on user view? Maybe. Let me try OSPF 1 restart or reset. Reset OSPF 1. Reset to mash. Control C. Reset OSPF. Oh, good. So reset OSPF, then the process ID, which is 1. So reset OSPF 1. Incomplete command. So question mark. Process. Good. So I think that is it. If we don't have to do that, so enter. This will reset the process. Yes. Okay. Good. So it's tearing down the neighbor relationships, blah blah blah. So we can do the same here. We quit to go back to user view. Then we do reset OSPF 1 process, like that. So we want to do this so that it can pick the new. It can pick the new router ID that we just configured. So again, quit, reset OSPF 1 process. Enter. Yes. Why? Good. Okay. So now let's give it just a few seconds so that it can reconverge and form new neighbor relationships. But you can just do display. Let me just go to system view. Display OSPF peer brief. It has already completed. So you can see now this is better. This is better. When you talk of router ID is 3.3.3, it's better. Otherwise, when it's picking the IP addresses, it becomes quite confusing to study it. So I prefer configuring the router ID using the number of the router. So if it's router 3, then 3.3.3.3. If it's router 2, 2.2.2.2. Okay, so now we can do display OSPF peer, just like that. Good, good. Okay, wonderful. So now this is the same thing we had gone through. So neighbors with the router whose router ID is 1.1.1.1. We can see that their router ID here is 3.3.3 connected via this interface. Connected via this interface. Okay, we can see that the DR has that address. The interface, this interface here, .3, is the DR, and this interface is the BDR on this particular connection. And here, the DR is this interface on router 2, BDR is this one. And again now, because we restarted from R3, you can see that now R3 indeed is the DR, and it has a higher, of course, router ID compared to router 1, which is now becoming the BDR. Okay, so let's move on and look at the next step. So the next step is to configure, step number 4, to configure OSPF authentication. Now, when it comes to OSPF authentication, we have two ways in which we can do OSPF authentication. Okay, so we have two ways in which you can do it. The first one is what we call interface authentication. The second one is what we call area authentication. So main difference between these two is that one is configured. The first one there is configured on interface view. The next one is configured on area, OSPF area view, But both of them work in a similar manner. When you configure OSPF on area view, it still applies on each interface, on all the OSPF interfaces for that particular process, OSPF process ID. So the one that is a little bit easier to configure is area authentication. In this particular case, we're going to begin by looking at, by configuring OSPF authentication by using the first method, which is interface authentication. So how to do that? You go to the particular interface that is participating on OSPF. So G0/0/1, which is connecting to R3. Then we type the command, R2 rather. Then we type the command OSPF authentication mod MD5. We can do question mark to see the list of hash algorithms that you can use here. So one of them is MD5. In this example, we are using MD5. On MD5, you can create multiple process IDs. So we just want to create MD5-1. Then after that, if we do question mark, you can see we can either cipher the password, that is encrypt the password, or save the password in plain text. So if we want to cipher the password, we use the command cipher, like that. Cipher, then we now enter the password. Here we are told to use the password HCAI-datacom-datacom, HCAI-datacom, like that. So if I press enter, then I do display this, you'll be able to see that we cannot be able to see the original password, which was HCAI-datacom. We cannot be able to see this. It is now ciphered. Otherwise, if we had used plain, then we could have seen it. So the next interface is G003. We simply go there and use the history command to access the same command, and just retype this hcai.com, enter. So now once we do that, check here. Let me clear this. If we do display OSPF peer brief, okay, we have a neighbor. We are not supposed to be having a neighbor. Again, maybe it's still working it out, but we are not supposed to be having a neighbor because they can't form neighbor relationship with us anymore, because we have a password now and they don't have that password. So let's just keep checking. We give it a few seconds. And we are not going to have any neighbor. Okay. Okay, let me see. Not yet. Let me just confirm on this interface. Have we configured display this? Have we configured the password? Yes, we have. It's there. How comes this interface is still able to form a neighbor relationship? Let me quit and find out whether it's still there. Display OSPF peer brief. Good. So not there anymore. So you can see that we don't have any neighbor. The neighbor list is empty. Nothing there. So in order to form neighbors, they must have the same password as we configured. So let's go on to R2, clear. Let me undo terminal monitor, then go to system view. So on R2, we want now to configure. On R2, we still want to configure on interface. So configure interface authentication on R2. So let's just configure on interface. Okay, so it is int 0/0/3. Okay. 0/0/3, which is connecting to R1. So the command is OSPF authentication mode MD5 1 cipher HCIA-datacom, like that. Okay. So if I quit, for example, and do display OSPF peer, we now should be able to form a neighbor brief. We now should be able to form a neighbor relationship with router 1. You remember here in router 1 we didn't have a neighbor, but now if we do that, we have a neighbor because the password has succeeded. They now have the same password, both of them. Okay, so let's go to the next interface that is connecting to our other guy. So for us, we are using G0/0/0, like that. So again, we use the command OSPF authentication. We use tab to autocomplete, MD5 to autocomplete, 1 cipher autocomplete, HCIA-datacom, like that. So quit. So if we display OSPF peer brief, we should not be having a neighbor relationship with R3. So this one will disappear in a short while. It will disappear after a few seconds because R3, we've not configured authentication on R3. So if we give it a few seconds, it should disappear. Okay. Why is my computer hanging? Brief. Okay, so you can see that we no longer have a neighbor relationship with router 3, only with router 1. So now we want to go ahead and configure. We want to go ahead and configure OSPF authentication on R3, but on area view. So area authentication. That is what we want to do. Configure area authentication. So the command is the same, only that now you have to go to that particular area. So UTM, we don't want to get. Okay, then we do clear. Then we go to OSPF. OSPF. It will go to OSPF area 0. Then we do authentication mode MD5 1 cipher HCIA datacom. I want to quit very fast, then do display OSPF peer brief so that you see the states. Oh, it has already gone to full. So we have already exchanged OSPF packets, and we are now in full state. So that is how you enhance the security of your routers by configuring OSPF authentication. So not OSPF interface authentication and area authentication. Implement OSPF packet authentication on OSPF interfaces. So remember that. So now we go to step number 5. We want to assume that router 1 is the egress. So router 1 is the egress, simply meaning that it's the one that is connecting us to the ISP. So everyone then has to send. So maybe router 2 and router 3 are on the core layer. Then this is our egress router that takes us to the internet. So we want to configure R1 to advertise what we call a default. We want to configure R1 to advertise what we call a default route. Advertise default route on R1. How to do that? We go into the OSPF process, then we use the command default route advertise always. So let's do that on R1. So here on R1, let's clear this. Then let's go to OSPF 1, then defaults, question mark. So when you do a question mark, you see some of the options you can enter is always. So always means you always advertise a default route. Normally, you use this if you've not configured on the other routers, like on R3 and R2, you've not configured any default route on them. So that's when you say always advertise this default route, so that others know that if they receive a packet and they don't know where to take it, let them forward it to me. So that's how you do it, always like that. So now once you do that, if we quit, then for example we go to this particular router R2 and do display IP routing table protocol OSPF, enter. We can see that we have an external route, a default route 0.0.0.0. So for protocol, yes, it's OSPF, but OSPF external. So it's called ASE, external. The preference for OSPF external routes default is 150. So for this default route, anytime you get anything whose network you don't have, send it to me. Send it to this next hop. Send it to router 1 on 10.0.12.1. Similarly, if we check that here, display IP routing table protocol OSPF, we can see that here again we have that static route, and we are saying if you get a packet whose destination network you do not have in your routing table, send it to me on 10.0.13.1, which is this interface of R1. So that is how we can configure default static routes in OSPF. Okay, so as we've just seen, R2 and R3 have learned the default route because they've been installed in the routing table. Now, we want to change the cost value of the interface on R1 so that loopback 0 on R1 can reach loopback 0 on R2 via R3. So, what does that mean? Currently, if we want to reach if we send a packet from loopback 0, we send a packet from here that is supposed to go to loopback 0 of this particular router. It's going to follow this route. It's going to be forwarded like this. But now we want it to go like this. Sorry. We want it to be sent to R3, and then to this guy. So in OSPF, how do you do that? In OSPF, you do that by increasing the cost of this interface. If we increase the cost of this interface, right now the cost of this interface is 1. The cost of that interface is 1. But we can increase the cost of that interface so that the other route can be the preferred route. So let's first of all confirm the cost of this interface. If we display OSPF routing table, we can see that if we want to go to the loopback, of R2, which is 10.0.1.2, the next hop will be the interface on router 2 that is directly connected to router 1, 2. This one here, this one in the background, if you can see it. And you can see that the cost is 1. The cost is 1. So similarly, that is the OSPF routing table. Similarly, if we do display IP routing protocol routing table protocol OSPF, we can see that if you want to go here, the loopback of R2, then the cost is 1, and the next hop is this particular interface, 10.0.12.2, which is this interface here. But we don't want it to go like that. We want it to go the other way around. So how to do that? We need to configure the OSPF cost. We configure a higher value. Right now it's 1 because it's using the reference bandwidth to calculate. So 100 megabits per second all over 1000 megabits per second, because this is a 1 gig interface, and therefore it's gonna give you 0.1, then it's gonna be converted just to 1. So to change that, we need to alter the cost of this interface 0/0/3, that one. Then the command is OSPF. If we do question mark, you can see that one of the things on OSPF that we can change on a link is the cost. So OSPF, then cost. And if I do question mark, you can see the cost value is supposed to be an integer between 1000 to 65,035. So we just want to take it to 10. Right now it's 1. We take it to 10. So enter like that. Okay. So we can quit. Then we can repeat the same command, display or IP routing protocol like that. So you can see now that in order to go to this network, in order to go to that network, the next hop has changed to .3. The next hop has changed to .3 with a cost of 2. So the one that was going to router 2 is no longer the optimal route because it has a cost of 10. So we simply choose this one that has a cost of 2. 1 and 1, so 2. Total 2. So that is how we can be able to achieve that particular configuration requirement. Okay. So we can verify that indeed it's passing through R3 by using the trasat command. By using the trasat command. So here we can do trasat -A to specify the source, -A, and then 10.0.1.1. We want to go to 10.0.1.2. So we can see that indeed this packet will be sent to R3, then sent to R2. Then sent to R2. Okay. So what else? Let's go to the next step. So the next step is to verify by testing the connectivity between the interfaces on different devices using ping. So can we be able to ping 10.1.3? Can we be able to ping it? Yes, you can be able to ping it. So it's because of OSPF. It has added all these routes. We've already seen that we can be able to trasat to .2, so you don't have to try it again. So we have verified that. Then the other thing we are supposed to do is shut down an interface to simulate link fault and check the changes in the routing table. So for example, we know right now that if we want to go from the loopback of R1, we want to go to the loopback of R2, we are passing through R3, then we go through, then we go to R2. But what if this link goes down? What if this link goes down? So we can disable this link on R1 and see how the routing table is going to change. So display OSPF routing, so that we just compare. So we can see right now, if we want to go to this, then the next hop is .3. But we want to disable this link and see how that table is going to change. So interface G0/0/1, like that. And then we shut. We use the shut command. Then I quit, and I repeat the same command, display OSPF routing. Display OSPF routing. So you can see now, if we need to go here, we need to go through the link on R2, and the cost of that link is 10 because we manually configured it to 10. We manually configured that particular cost to 10 for that particular interface G003. So as we said, with dynamic routing protocols, they can be able to respond to network topology changes, and that is how it achieves that. Okay, so let's just undo shut on that particular interface. So undo shut, like that. Then we do the very last thing that we're going to do is on this question. I found it quite intriguing. So in step 6, what is the path for R2 to return ICMP packets to R1? Try to explain the reason. So maybe we can try. So what is the path? We know that as it is right now, if we are sending a packet, if we are sending an ICMP request, then it's gonna go it's going to go like this because we've configured a higher cost on G003 on R1. So the request will go like this. The request will go like this. The request will go like that. But what about the reply? Where will the reply go through? The thing is, the reply will be sent like this. Will be sent via this link. So we can use packet tracer to see that, not packet tracer, but we can use Wireshark to see that indeed the reply will go through here when we do a ping from R1, but the request will not go through there. So let's do it. Let's do data capture here. So start data capture. It's gonna open up Wireshark. Okay. So I hope you're seeing some things here. You're seeing that we're having OSPF hello packets. OSPF hello packets. Now, even before we do that ping, it's important to just emphasize that indeed OSPF packets, hello packets, are sent to the destination address. They are sent to the destination address 224.0.0.5. So that is the destination address of OSPF packets. The other thing you cannot excuse me. The other thing you cannot is the time between which OSPF packets are retransmitted. So you can see the source, then the source, then you can subtract. You can subtract the time to find out the difference. So normally, OSPF packets are sent after every 10 seconds in order to check that your neighbor is still active. So OSPF, to maintain and monitor neighbor relationship, OSPF uses two timers. It uses two timers. The first timer is called the hello timer. Hello timer. Normally the hello timer or hello interval is 10 seconds. 10 seconds. Otherwise, we also have the dead interval, and I thought you saw it. You might have seen it. Dead interval or dead interval timer. Normally, this one, by tradition, it's 4 times the hello timer. And the value of the hello timer, again, it varies from network type to network type. So read more about that. So the dead interval will be about 40 seconds, for example. Now, the dead interval is the amount of time that an interface will conclude that the neighbor is no longer functioning if they don't receive a hello packet from them within that particular amount of time. So, for example, in broadcast and non-broadcast multi-access networks, you don't receive a hello packet within 40 seconds, then you conclude that your neighbor is no longer active, is no longer up, and therefore you have to reconverge. Okay, so these are the hello, but we are not interested with the hello. This time we want to do a ping. Remember, what we really want to do is to see whether the reply, when we do a ping, we already know that if we do a ping, the packets are going to be sent to R3, the request, but the reply is going to come through this. So we want to see whether this particular interface here is going to capture the request and the reply, or only the reply. So let's see that by doing the ping. Let me just place this window aside here. Then here I have Wireshark. Okay. I can filter Wireshark to just give us ICMP and not OSPF packets. Let me see, filter. We just want ICMP. Okay, good. So let me do the ping. Quit. Let me clear that. Okay, so ping negative A, the source is 10.10.0.0.1. Oh no, I think it's 1.1 like that. Then the destination is 0.1.2 like that. So if we ping, we can see that we've captured the packets on that particular interface, and you can see that all those packets are reply packets, and they're coming from this source, from R2.2, and they're going to R1.1. So why is that the case? Why is the reply following that route? What is the reason for that? Reason for that in my thinking is because when you go to R2, we only configured the cost on the interface on R1. But when you go to R2 and do display OSPF routing, the table, you can clearly see that if you need to go to this guy, which is the loopback of R1, then the next hop is 10.0.12.1 with a cost of 1. So that's why the reply have to be sent to this guy. That guy is this interface here, this one. So that's why we've been able to capture the replies through here. So ladies and gentlemen, thank you for your time. I hope you've enjoyed and learned quite a lot about OSPF. These are just but the basics. If you want to learn more, of course, we have a lot of it on hcip.com. So consider exploring that content on my channel. Thank you. Be blessed. Asanteni sana.